Dear students, welcome to another day's lecture in Industrial Engineering and Quality Control. Yesterday we saw about the string diagram. Today let us move on to travel chart. The string diagram is a neat and effective way of recording the movements of workers and the materials when we are studying about the method study. These are all part of the study of method study. Okay. But there is a disadvantage with the string diagram. What is the disadvantage? It takes long time to construct, and also if number of movements are many, then the diagram becomes very complicated. Okay, so therefore, in order to record all such kind of complex movements, we move on to this chart, that is the travel chart. Travel chart is a quick and easily manageable technique. Okay, now the definition of travel chart is given here. A travel chart is defined as a tabular record. That means it is more like a table. Okay, tabular record of presenting quantitative data about the movements of workers, materials or equipment between any number of places over any given period of time. Suppose if we observe for 1 hour, that is the given time. Okay, and in our workstation there are say some 10 workstations, 10 machines also there. From these 10 machines, from one machine to another machine, the people, workers may be going, or materials may be moving. Okay, or the equipment may be moving. Okay, so those are the things which we have to observe. Okay, in travel chart, the path is not traced, but the number of movements are indicated. So here what we are doing is we will be counting the number of times a person is going from one machine to another machine, for example. Okay, so the travel chart is always a square box. You see, it is a square box. Okay, remember this. And it is having smaller squares within it. Each small square represents a workstation. For example, in your textbook, this diagram is given. It is not easy for me to read. You see, this is the square. You see, this is the square. And here some 10 machines are there, and here some 10 machines, or 10 departments, you can say, or 10, okay, 10 locations, you can say, okay, anything, 10 machines. Okay, so now here there is one square, then this is one square, this is one square, like that. It is made of 10 horizontal squares, 10 vertical squares, totally 100 squares in a big square. Okay, that is how this travel chart looks like. Okay, so the travel chart is always a square box. Okay, if see why a square box? If 10 machines are there, we write 1 to 10 here, and again we write 1 to 10 here also. If 6 machines are there, 1 to 6 this side, 1 to 6 this side. Therefore, it becomes a square. Okay, so it is always a square box, and it has a smaller squares within it, and each small square represents a workstation. Okay, or a machine or department or anything. Okay, across in the square, sorry, here it should be a cross in the square, represents the movement to that workstation. See, in this diagram, you see, it is hard to see, but you can see one small cross is there. Cross means in into symbol. Okay, multiplication symbol. Are you seeing? Here there are 3, here there are 3, here 1. Okay, here there are 2. Okay, are you able to see? So these are the crosses. A cross in the square represents the movement to that workstation. So that means what? You see, this is the workstation number 5. Okay, works. So across here means from second workstation to fifth workstation somebody has come or the material is moved. Okay, that's why there's that cross there. Okay, along the travel chart, often a bar chart is drawn to represent the frequency of movement to and from the workstation. You see, beside this, see here there is a bar chart. Okay, horizontal in the vertical thing there is a bar chart and also a horizontally. So this shows the frequency. Okay, frequency. So you see, this is from, you see, this is movement from. So how many things originated from station 1? In all this, if you see, there is only one cross here. So this frequency is 1. So, and if you take second one, how many crosses are there? Here I am seeing 1, 2 and 3 are there. So this frequency is 3. If you see this, how many crosses are here in the third station? 1, 2, 3, 4, 5, 6. Here there are 2. So totally 6. Like this, you know. So how big is the frequency? Accordingly, this bar chart will be plotted. Okay. So bottom, what you are seeing, you know, or you can say this is the horizontal or this is the vertical thing. In the horizontal bar chart, you are plotting the frequency of movements from the workstations, and in the vertical thing it is movements to the workstation. So 2, 1, how many things came? See, here you see 1 and 2 here. So 2 crosses. So from 2 different machines to the station 1. Okay, some material is moved. Like that it is. So accordingly, if you see, this is the maximum frequency. How many 7 are there? Let us see if the 7 crosses are there. 1, 2, 3, 4, 5, 6, and here 1, 7. Like that. Okay. Okay, it is not easy to see, but no, you can note, you can see in your textbook, which may be more clear. Okay, so come, let us see what they are saying. So see, the vertical bar chart represents the frequency of movement from the workstation, and the horizontal bar represents the movement to the workstation. Okay. Now let us see the next one. Steps in construction. How do you construct? Okay. You see, first draw a square grid. Mark various departments by numbering them on both sides, from left to right and from top to bottom. That means left, see, here it is left to right and here from top to bottom. Okay, we draw. Okay, we number them. Okay, then mark the diagonal in the square. uh, uh, see yeah, this is the, see, this is the diagonal. This is a diagonal. Can you see, this is diagonal? That means, you know, you cannot originate from 1 and you cannot go to 1. So this is, you know, like, I will show you another diagram here. Yeah, here, you know, this is a little more clear. You see, they have accounts department, goods in department, stores department, production department. How many? 4 are there. So like that, here also accounts department, goods in department, stores and production department are there. There it is, numbers are given. Here directly the departments names are given. So you cannot originate from accounts and go to accounts. So this is crossed. So all these diagonal things. Similarly, from goods to goods you cannot go. So this you have to cross. From store to store you cannot go. You have to cross this. From production to production you cannot go. You cross this. Like this, you know, these things. So that's what, you know, here a diagonal is drawn like this. Okay. So you draw the diagrams. Then what you do, see, if there are 10 workstations, now how many you know, crosses will be there? How many squares will be there? 100 will be there. Okay, now what you have to do, suppose you are moving from station 3 to station 9. So see, this is from, so suppose station 3 here to station 9 here. So what you do is you start at 3. Always you should start from the top, because here it is movement from is given. So from 3 you come down to 9. Why it Okay, so it is going to 9. So from 3 to 9, so you have marked a cross like that. Okay, you mark a cross like this, and you do everything like that. See, from originate here, you see, suppose from 5 you are going to 3, so 5, from 5 you come to the workstation 3 and you mark a cross here. And suppose from 10 you are coming to 7, and that 3 times you have come means 3 crosses you have to put. Okay, like that, 3 x's. Otherwise, all travels are recorded in the same way, always starting at the top in the square and traveling vertically downward. Every time, in order to make a new record, the study man or the work study man will go to the top of the chart. He will go to the top of the chart, here originate, and go against that number, and you mark. Okay, like that you have to do. And finally, what you have to do? Okay, after the chart is completed, the number of crosses in each vertical and horizontal are added up and the bar charts are plotted in order to provide frequency of movements from to and from each department. This way you will understand. You see where more traffic is there. Whichever is bar is more, no. See here the bar is more, longer. So that means what? You see, to workstation 7 more people are coming. From workstation 10, more people are going. Like that it is. So there you have to see, you can think of locating that workstation closer or something like that. In this diagram, let us see here. Now you see here a little different way of showing it. Okay, these are visits in 1 week. This is the, see, every time there we have marked with crosses. Here they are putting, like this mark, just drawing one vertical line like this. So if 2 vertical lines means, count of occurrence 2 times. If 3 vertical lines means 3 times. If it is 8 times means 1 2 3 4 cross 1, that means this is 5. As in frequency distribution you must have studied. Okay, and this is 5 and 3 is 3, 8 times. That means from what, from production you have started, gone 8 times to accounts. From stores you have gone to accounts 2 times. From goods you have gone to accounts 3 times. Like that it is. Okay, so see, afterwards, what you can do is 1 2 3 4 5 5 and 8 13. So here you can write the number 13, and there are some numbers here. These numbers indicate the distance between the places. You see, from stores to account is 120 meters. From goods to accounts is 112. And now you see, now 3 into 112 will give you one figure, and 2 into 120, this will give you one other figure, and this 8 into 90, this will give you one figure. And if you add up all this, you will get a distance like this, 1296. You see, this is the total distance. You see, like that for everything you do, vertically and horizontally you do. Okay, thereby, whichever figure is more, that is, the frequency is more. Here where it is more, here this is more. Okay, so we can think of locating our department in a central location, such a department, this accounts department. See, people coming from accounts and people going to accounts are more of all the things. So this department can be centrally located, thereby all these distances can be minimized like that. So this is how travel chart is drawn. So therefore, what are you aiming at? You have to minimize the traveling of the people, or traveling of the goods, or traveling of the equipments from one department to another department. So this way, you can improve the location of the machines or locations of the departments. Okay, so this is about the travel chart. Okay, now next, moving on to the next topic. Now this is Therbligs. So Therbligs, earlier, I've talked a little about Therbligs. You see, actually this is suggested by Frank Gilbreth. Frank B. Gilbreth. So Therbligs, this this Therbligs has come from his name's spelling. If you read it in the reverse direction, only the first two letters, they take it as it is, and afterwards it's see Therberlig. See, Therblig. So from Therbligs came. Okay, Therbligs were suggested by Frank B. Gilbreth. So the word Therbligs is an anagram of his name. Anagram means something maybe derived from his name. Okay, so he differentiated. You see, this man is studying about method study. So when he is studying about method study, all these people, they thought about it and they have differentiated. Now this man differentiated 18 fundamental hand and eye motions of the work cycle. Now this man is concentrating upon the person. Okay, the hand motions, hand and eye motions, these are the things. 18 fundamental motions he has identified. Every Therblig is represented by a symbol, a definite color, and a word to record the same. So three things. A symbol is there. You see, 18. We will be studying about these 18 fundamental Therbligs. So each Therblig has a symbol, a color, and a word. Okay, and the various Therbligs along with their definitions and symbols are given, color codes are given in the table. Now let us see. So this is the thing. Now first Therblig is assemble. To assemble, you see, to assemble, what is the symbol? You are seeing symbol like a hash type symbol. Okay, two forward leaning lines and two horizontal lines. Okay, this is the symbol, and it is represented by a letter A for assemble, and its color is violet. Okay, assemble, this is the symbol, and this is the color violet. You see, what is assembling? Assembling means putting objects together, like if you are assembling nut and bolt. So nut and bolt, you see, you have to take nut, and in the bolt the threads, you have to assemble it, you have to put it together. Okay, so second one is disassemble. Disassemble is see, the horizontal one of the horizontal lines is missing. Okay, so this is the disassemble, and the symbol and the letters we are using is DA. D for dis and A for assemble. Disassemble. And if this is violet, this is light violet. Now what is the meaning of disassemble? Disassemble means separating different parts of an assembled unit. That means what? An assembled unit, nut and bolts are there, suppose. You are making them separate and putting them in two different trays. See, this is called disassembly. Okay, then avoidable delay. Avoidable delay is in this fashion, and it is AD. And lemon yellow, a delay within operator's control. A operator or worker, it is within its control, could avoid it. But there are certain unavoidable delays. See, something is broken down. Okay, you can remember, it's like a man sleeping. He is purposely sleeping and wasting time. So that's why this is avoidable. This can be avoided. Whereas the machine is broken down, that's why this man also is broken down here. Okay, unavoidable delay, UD, and color is yellow. A delay on which operator has no control. Suppose some delay has happened, some machine breakdown is there, or some such thing, some electrical problem. So what can he do? The maintenance people should come. Okay, next, transport loaded. You see here, this is transport empty, this is transport loaded. Transport loaded is TL, transport empty is TE, it is green color, this is olive green color. And transport loaded means what? Moving an article from one place to another place is transport loaded. Transport empty means moving empty. That means when there is no load, you are moving. You see, a truck is going with the load and without load. You understand, no? So that is transport loaded and transport empty. Then search. Search is, like in the eye is there and the eyeball. So you can see the eye and the eyeball. This is searching SH and it is black color, and that means what you are hunting for an object. Search. And plan, this is the symbol PN, plan. These are the letters and brown color. And planning means what? Mental reaction before action. You see, before doing something, planning means thinking before doing. That is the planning. So you have to do thinking is done by mentally. Okay, so mental reaction before action. Okay, or you can say mental action before reaction. Okay, anyway, so this is the plan. And the another one is rest. Like this man is sitting, like that. Rest, or orange color. An allowance, idleness, or pause. You see, this is not delay. The delay, this is purposely that man is delaying, okay, with the which is within his control. And this rest, it is permitted for him to take a little break, a little allowance, an allowance, or a pause to overcome fatigue incurred during previous work. That is the rest. Okay, now next we, I have taken this 9 again. Okay, now come to the 10th one. 10th is position. Position is like this 9 number. Okay, P is the letter and color is blue. So positioning means turning to line up, or orient, or change position, changing position, or turning to line up. Suppose all the people are standing in a queue, so you go and stand at the last, so that is lining up. Okay, orient means taking a direction. Suppose uh, you know a dog is coming running. Now you have to see which way to run. Okay, yeah, you found one place of escape, so that side you are turning and turning to go. So that is orienting yourself, and then you flee from the dog. Okay, anyway, next, find. See, search was the eyeball was here, whereas find, the eyeball has come to the center. That means your eye is fixed on the object, like that. Find, F letter, gray color, and mental reaction at the end of the search. Okay, inspect means this is again eye, but it's in a vertical it is there. Okay, I for inspect. And burnt ochre, I don't know what this color is. Okay, you can see in Google which color did come to. Okay, examining an object for its quality, inspection. Okay, then preposition is like this, like 8, but only that here inside it is erased. PP, preposition. Pale blue, locating an article in predetermined position so that it is ready for use. Prepositioning means, suppose you want to drill something, a plate. So first you have to position the plate, just position that point where you want the drill to be done, exactly under the drill. That is prepositioning. Okay, then grasping means with the hand you are grasping. It is like a hand, you are grasping. Grasping means holding, हाथ से पकड़ना, that is grasping. Okay, ये letter G है और color red है. Taking hold of something, catching something. Okay, use is like you like your hand is cupped and it is facing upside. That is using. Now it's purple color. Manipulating means what? With the hands, if you do anything that you can be calculated, that can be said as manipulating. Manus means hand. Okay, that's why it's manipulating or causing a tool to do its function is using. Say, suppose with a screwdriver you are tightening a screw or a thread. Okay, that is manipulating. Okay, that is using. Then hold is this symbol H, gold ochre, and Retention after grasp. Holding means what? You have taken the screwdriver in the hand and you just held it for some time. That is hold. Then select. Select is an arrow, ST, light gray color, choosing one object from amongst many. Suppose there are three students, and out of that we call one student. That is, we have selected one student for some certain work, like that, selecting. Okay, like that. Then release load. You see, load is released. You see, when here it was, transport loaded is like this. The reverse of it is release load. Release load means karma in red, releasing an object. Okay, so these are the 18 Therbligs which our man, this management thinker Frank B. Gilbreth has suggested. Okay, so these are used. Where do we use it? We use it for SIMO chart. Some people call it SIMO chart, SIMO chart. Okay, you can call it anyway, no problem. Okay, actually, what is SIMO chart? A SIMO chart is defined as a chart often based on film analysis. Film means, like our cinemas in the olden days, they used to take, even photos and all, they used to take, so camera film used to be there. Nowadays, you people may not be knowing much because you are using digital cameras. Okay, digital cameras, mobile phones, for taking the pictures. But in the olden days, there used to be films on which, you have to take exposure, and then you have to go to a dark room, and under chemicals you have to wash it. You will get negative, and you have to develop into a positive image, positive photo. That's how it used to take so much time for photos in the olden days, even when we were small. Okay, but nowadays, all the things have become much faster. Okay, anyway, so a SIMO chart is defined as a chart often based on film analysis. Now it may not be film analysis. You can say it is a camera analysis, camera photo analysis, camera video analysis. Yeah, still image analysis or video analysis, you can say like that. It is used to record simultaneously. Okay, on a common time scale, the Therbligs or graphs, we have studied Therbligs, now we have seen there is 18 types of Therbligs. These Therbligs we are going to use here in SIMO chart. Okay, that's why we have seen what are those symbols and what are the notations and all those things. Okay, on a common time scale, the Therbligs or graphs of Therbligs performed by different parts of the body of one or more workers. You can at a time take one more worker or more than one worker, and their body parts, how they are performing. Those are the things we have to chart with the help of the Therbligs on a common time scale. And what you get is a SIMO chart. SIMO chart is a graphical representation. This is the definition of the SIMO chart. If somebody asks you what is SIMO chart, this is the definition you should give. SIMO chart is the graphical representation. Graphical means, it is not simply, some text or some table or something, but it is graphical. Some pictures will be there. So that's why graphical. It is a graphical representation of micro motions. See, till now what we have seen are motions. These are micro motions. Micro motions means very tiny or very small movements of the hand, limbs. Limb means, limb means what? Body parts like hands and legs can be called as limbs. So sometimes, mostly we'll be working with our hands, but there are people who work with the legs also. You see, when we are driving in a car, you use legs for applying brakes, you are for pressing the accelerator or for pressing the clutch. You are using, okay, even when you are riding a motorcycle, you apply brake with the help of your leg. Okay, so these micro motions of the hand or limbs by the operator under study. So one operator we can choose, or more than one operator we can choose, and his body parts or his limbs, that is legs and hands, how they are moving, and what are the micro motions. Micro motions means, see, motions when we were studying, we could study it in millimeter, in minutes, or in seconds. But when you come to micro motions, that won't do. Then what we have to do? We have to, okay, then what we have to do? We have to find a unit which is small enough. Okay, let us see, what is that unit. Okay, while preparing a SIMO chart, the movement of each hand is recorded in a separate column. So for a left hand there will be a separate column, for the right hand there will be a separate column. The SIMO chart shows on a common time scale. That's what we have seen here, common time scale. Okay, the simultaneous minute movements, this is minute, not minute movements, minute movements or micro movements performed by the two limbs of an operator. It is also called SIMO. SIMO actually, this is, if you expand this, it is simultaneous motion cycle. SI they have taken from this first word, and MO they have taken from the second word, and they have come across, come with this name, SIMO or SIMO, simultaneous motion cycle. So in Vivavos and other things, people ask, what is they expand the full data, what is the do you tell the full name of SIMO? So you should say simultaneous or simultaneous motion cycle chart. Okay, see, because it records simultaneous motion. Simultaneous means what? Together, that is left and right hand both together you are doing, that's why it is simultaneous. Okay, in time chart the two columns are so aligned that a horizontal line drawn through them at any point would indicate simultaneous actions of both hands. Um, okay, when we see the diagram you will understand. Okay, chart. Okay, this is a simple chart. This is a SIMO chart. Okay, the operation here is to assemble, not to a bolt. The operator's name can be given here, part name can be given here, part number can be given here. Now this column, left hand motions are described here, and at the right side right hand motions are described. Okay, and what left hand is doing, those Therbligs, you can call it symbol or Therblig also here. What T, G, T, L, H. Okay, T means what? Transport empty. G is grasp, isn't it? G is grasp, yeah, you can see here. And TE is transport empty, like that. Okay, and TL is transport loaded, H is hold. Okay, and here T, G, TL, P. And here time is mentioned. Time is given some as some number 10, 8. Is it seconds? No. You see here it is mentioned. The time scale used in SIMO chart is represented in winks. Wink. Wink means what? Wink means, if you shut your eye and if you close your eye and open, that is a wink. Just you don't even realize how little time it requires just to close and open. So that is wink. Wink is, in the bracket it is given, it is 1 upon 2000th of a minute. So 1 minute has a 60 seconds, and in 60 seconds, can you count 2000? No, you cannot count. That means, this wink is very short duration, very short duration. That is wink, 1 upon 2000th of a minute. Okay, So these are the things. What your left hand is doing to the bolt, it has gone, transport empty. Whereas this one right hand has gone to the nut. Okay, both transport empties. And how much time it is required? Both, suppose this left hand goes to the tray, right hand also goes to the tray, and from the center. So both are taking same time, 10 wings they are taking. So total time is the maximum of these two will be the total time in that case. Okay, and then with the left hand you are grasping the bolt, with the right hand you are grasping the both are some bolt only. Okay, one should have been nut. Okay, here it should be nut. Some mistake here, typing mistake. So this is holding the this is grasping the bolt, and this is grass. Oh, here group also is mentioned. It is not group, it is grasp the bolt, it is grasp the nut. Okay, this is G. And how many wings are required? 8 wings are required for both. So uh, this is the cumulative time. This is cumulative time. Cumulative time is, say this greater of this 2 is 10. Now greater of this 2 is 8. 8 plus this 10. 10 plus 8 is 18. Like this will go. Okay. And then now you take those two and bring to the center. Now with the object you are coming. Okay, towards the right hand and towards the left hand, or you can say towards the assembly area. So this also takes transport loaded, this takes 10 wings, 10 wings. So totally now 18 plus 10 is 28. Okay, now hold the bolt, and here position the nut over bolt. Okay, now these timings are different. This is taking only 8 wings, whereas this is taking 10 wings. So what we should do, we should take the larger of these two values, that is 10. So 28 plus 10 is 38. So cumulatively how much time you required for doing this much action? That is 38 wings. Okay, like this, you have to plot this chart, SIMO chart. Thus, the SIMO chart enables the analyst to know at any instant what left hand does and what right hand does, or what both hands do. See, if you take any horizontal line like this, at that time what left hand is doing, what right hand is doing, you will know. Okay, so simultaneously you'll be able to know just by going horizontally at any part of this SIMO chart. Okay, so SIMO chart is generally used for micro motion. You see, micro means what? Actually micro means 10 to the power minus 6 is micro. With mu we represent micro. Micron, you say, no, micro, that is very tiny, micro motion. Okay, SIMO chart is generally used for micro motion analysis of the chart cycle. Repetitive jobs, again this is a repetitive job. Okay, see, mostly all these things we do for repetitive jobs only. High order skill jobs, and finds application in jobs like component assembly, packaging, repetitive use of jigs and fixtures, inspection, etc. For all such things, your SIMO chart can be used. Okay, here there is another example of SIMO chart. See, left hand description, right hand description. Here a serial number also is given. That means totally there are 10 distinct operations at any given point of time these hands are doing. Okay, so the first one is searching and lifting. Searching is SH and lifting. Oh, here we have not used those symbols, is it not? Those symbols, these symbols we have not used. Where is my mouse? Yeah, these symbols, but instead we are using these things. Okay, maybe some other people will be interested to use those symbols. Okay, so clamping workpiece, that is pre-positioning, and this is do the hand filling operation. What is U? U is use. Yeah, U is for use. And see, you see here, no, when the left hand is doing something, the right hand is not doing anything. And in the center, no, these cumulative timings are given, individual timings are not given. See, in this example they have shown like that. Okay, so totally here there is a mistake. This the 3.2 3.4 must have been here. So this is the total time that is required for these things. You can just go through. See, first, searching and lifting. Searching and lifting with the left hand you did, and right hand is not doing anything. And then right hand is doing something, opening the vise. This is use. Okay, and it required. Now, now this point 4 cannot be wink. Now this must have been some what we should say. How much does it appear? It appears like minutes. It appears like minutes. Okay, but a micro motion study, if you are doing hmm, micro motion study, if you're doing, you should take wings. If it is not micro motion study, see, if it is a motion study, then you can take in minutes and seconds. Okay, like that. Okay, then this is prepositioning, this is also prepositioning. Then in the 4, left hand is not doing anything, right hand is doing something. What is that? Taking the file. Okay, transport loaded. Okay, then use, transport loaded. Okay, inspect, use, and all these things. You can just go through, pause it and go through this. Okay, this is how the SIMO chart is. Okay, so that's all, friends. So today we'll stop here, and we'll continue in the next lecture. Thank you.